Hey folks, just a quick one. Within a few minutes of the last video going up, I had a viewer leave a comment asking why I ran my LED down the column rather than running it from, as I've done here, with the anodes in the negative rail. It doesn't really matter as long as you're conscious of how you have pinned this out. If you're doing this in an environment other than your own tinkering, and let's face it, it helps you in your tinkering to document as you go. But if you document that you did it this way, anybody should be able to follow along and figure it out. What I did was a wiring diagram, if you think about it, directly on the board. The rest of it is just procedure for how you do things. So the viewer comment was, again, why not run the anodes or the negative side of the LED off the common rail? You can. There's no reason you can't. Just following up on that thought a little bit, there's one disadvantage to doing that. And let's just wire this up the way the viewer's comment read is that why would you not just run the ground over and bring your signal itself, the high and low pin, to that common rail? Now, could you do it? Yeah, but I'm going to show you why you don't want to do this. Okay, we're going to plug in an LED. You see what's happening? It's triggering with our system LED, pin 13. Can you see that? If you look at this pin down here, or this LED down here, it's triggering. So what's that tell us? Uh-oh. Is our entire rail now getting switched on and off with that pin? Well, yeah. So hopefully that makes that point a little bit clearer as to why you don't want to do that. Let's follow on with this some, though, because this did bring up a couple really good thoughts. Let's say we're in a controls environment, whether it's industrial or HVAC or whatever, and we have our control cabinet side, which we'll say is the Arduino, the microcontroller. Now we've done something useful. We'll say that the Arduino is locked away in a cabinet somewhere, and you cannot see this series of LEDs. Okay, so we know it activated. That whatever our function is activating because we're bringing that pin high, and that pin is shared with the LED on the board. So wow, that's good. Okay, I have visual confirmation of what's happening out here. But look here, on the control side, I have a power LED. How can we continue that out? Well, that's another easy one. We're going to come over and we're going to catch our 5-volt side of the power supply and power up our rail the proper way. Our rail is actually being powered by the Arduino itself, by our microcontroller power supply. Now, let's bring that circuit up, that LED up. Okay, so now we have our process LED. Whatever we're trying to do with this pin is pulsing on and off, and we know that our green LED is our power. Again, controls cabinet is the Arduino. operator station, we'll say as an example, is our breadboard. We can prove that out. Okay, our processes have stopped. Our power is gone. Let's reapply power. What happens? On the control side, we see our power. I need a pointer because of my fat hands. But yeah, we can see our power and we can see our process. The LED. Operator side, we see our power, we see our process. We can now move this out to our load. In this case, I'm just going to hook up a quick relay. Very simple relay. And to make this work, I need our ground. I need our constant 5-volt power. And I need our signal. In this case, we're going to piggyback off the LED. Now you can hear our relay energizing. Now at the relay, you also get a signal to show you that it's activated. Sadly, in our case, it's not a yellow LED. But you get the idea. Now you can see that, yes, the LED should be energizing. The operator can tell that it's energizing. And the controls cabinet can visually see that it's energizing. We can tie this in one step further with Josh's question about controls by with a safety following Josh's question. So let's come over here. We're going to pick up our control signal. We're going to bring the control signal down to our switch. We have the signal here, but our safety isn't energizing because the door is open. Let's close the door. Right, the door is closed. Our system is working. Somebody opens the door. Ideally here we would induce a fault indicator, which this switch has the wrong or is not the right wiring. Yeah, you can see it. The switch is not the right wiring, but you would say that when this switch is activated, right, this still indicates a fire, a trigger, but this should be red to indicate a fault, but I don't have the right switch. There would be additional logic in there too, so that when this is energized, right, so now we're in the safe position. We have a yellow LED. When this fault condition is triggered, in theory, the red LED should come on and it should deactivate this side of the circuit. Again, that can easily be rectified, but I think is beyond the scope of our discussion right now. Let me remove these wires and get this one back in. But yeah, so now hopefully that makes sense. So what have we done here? I've shown that it is not a good idea to run that entire top rail off of your switched pin. Go directly to your load or directly to your process indication and then on to your load from there. I hope that makes sense. If not, post up in the comments. See ya.